Okay, so we're going to actually work on two problems that involve car dealerships trying to arrange different cars that they have. So for this first one, it's going to be a little simpler, and it goes that a dealership has 5 different models of cars shown in the showroom. The 5 cars are to be displayed in a straight line. 3 of them are blue, 1 is black, 1 is green. What is the number of ways that we can arrange them such that no 2 blue cars are together? Okay, well, from this information, we can actually just say, let's write down all the important info we had. So they said, okay, one was that we had 5 cars. The next one was that they said we have 1 black, which I'll just label as 1 blue, or 1B. The second one was 1 green, which I'll just do as 1G. And then we have 3 blue cars, which I'll just put as 3B. Okay, so we want to arrange all 5 of these cars such that no blues are together. Well, this should be pretty intuitive because we'll say that if we are to create our lineup here visually, we say that we have a space for each of those cars and no blue cars can be together. That means that they have to be separated by 1 space each. Okay, and then what's our other choices? Well, we could either put the black here or the black here. And we could either put the green here or the green here. Okay, so what does this mean for our solution then? Well, now that we know no blue cars are together, it's all about selections at this point. So we would say, if we start with our first square, we have a choice of 1 blue. So we can say between the 3 cars, we have all 3 to choose from. Then we've already slotted 1 for blue, so now we only have 2 cars that are blue to choose from, and then we only have 1 blue to slot there. And same kind of logic goes with this one. If we're choosing between a blue and a green, technically we have 2 choices. And then if we go to a green or a blue at that point, depending on what we chose in the first one, we're only going to have 1 car left to select. So then what does that mean our final form is? Technically, we're saying it's a factorial because it goes down in 3, 2, 1, and then same thing for the blue and green, it goes from 2 to 1. So you would just multiply those together, 3 factorial times 2 factorial, which is going to give us our solution of our lineup, which is technically 6, which is equivalent to 3 factorial, times 2, which is 2 factorial, which is 12. So there are 12 different ways to line up these 5 cars such that no blue is together. Okay, so we got a second problem here, and it states the exact same type of problem where we're dealing with the car dealership, and it says 8 cars, we have 3 red, 3 blue, and 2 yellow are to be parked in a line. How many unique lines can be formed if the yellow ones must not be together? And then assume that the colors of the cars are the identical. So for this one specifically, we're saying that if we have 3 red cars, they're all the same model. Okay, well, let's write down all the info we were given for the problem here. So they said we have 8 cars total. And then they say we have 2 yellows, which I'll put as green just for the sake of not having a yellow marker. 2 yellows, we have 3 blues, and we have 3 reds. Okay, so what the strategy is technically we want to form a line of 8 cars. So 1, 2, 3, 4, 5, 6, 7, 8. Technically, if we were just to say, let's line them up and it doesn't matter about color, we would say 8, 7, 6, and go down to 1, which technically corresponds with 8 factorial. But they gave us a problem that states that if we have 3 reds and they're the exact same model, that means we have to eliminate for our repeats. Because if we slot a red one here and then a red one here, the order won't matter between those 2 because they're the same model, and it would just cause a repeat. So we're going to say 3 factorial for both the red and the blue, and then 2 factorial for the yellows being repeated. But now, if this is the total arrangements, ignoring that the yellows can't be together, now we have to say, what's the total? Then take away the cases where they are together, and that will give us the times that they aren't together. So what that means is let's combine one of our blocks, which reduces the total numbers that we have. So if we say that our 2 yellows are together within 1 block, the case where they are together, that means we have 7 factorial, 6, 5, down to 1, which means we only have 7 blocks to arrange. We eliminate our repeats for our red and our blue, but because the yellows are together, we don't eliminate any repeats. And then that states that our answer which will be 420, means that we have our total arrangements. How many ways can we arrange all 8 of these cars with no restrictions, minus how many ways we can arrange it with the yellow cars together. Well, if we say the total arrangements minus the ones where they are together, that technically equals 428 ways to arrange it where they're not together.